high school geometry do you have to say, I know the two sides are parallel? You also have to know their, nope. What proves two things are parallel? The slopes. So you also have to say the slope of, was it AT? So on your paper, you would have slope AT. You would have written this out. I'll write it on here just to be a little bit more clear. Slope of AT was what? Rise over run. 3/4. And then the slope of AT was perpendicular to HA? TH, thank you. No. AT can't be parallel to TH. HM. MAT, yeah, HM. So what's the slope of HM? 4/7. What? Ooh, somebody can't count. Who can't count? My 7s or my 8s? Is it 4/7 or is it 4/8? Okay, so now you all have told me that you know a trapezoid has parallel sides. And if my sides are parallel, then my slopes have to be equal. Are those two things equal? No. Ooh, what if I suck at fractions? How do I figure out? What if I look at this and I'm like, oh my God, I don't know if these two things are equal because I don't know how to reduce fractions. Which, let's be clear, some of us, that's not our strength. Divide them, right? So I divide this on my calculator, it's 0.75. I divide this on my calculator, it's not 0.75. So then, are these two parallel? So is this a trapezoid? No. So I have no parallel sides. Nothing is significant. Nothing is equal, right? How many of you did the distance formula for, Jesus, you can leave it open. Thank you. How many of you did the distance formula for all four sides? How many of you had something that looked like this, where you ended up drawing boxes around it? Yes? Thank God. Step 1. If you don't have something that looks like this, and let's be clear, some of you still have this graphed incorrectly. If yours doesn't look like this with numbers on it, right? Just don't just draw the picture because but there's numbers, there's decimals. Why would I as a math teacher go, oh, I know that this student has done Pythagorean theorem? Because there's decimals. When you're square rooting, you get a lot of decimals. So the correct name of this is quadrilateral. Okay? So you need to be careful about calling something a trapezoid because it really did look like a trapezoid, didn't it? It looked like those sides were going to be parallel. So be careful. Okay, we're going to do one more. So wipe your board clean. Okay, so there's your 4 points. Those of you that your shape was a little bit off, you might want me to have the English speaking correctly. You might want me to look at your first couple of points to make sure you've graphed it correctly as you're going, okay? Board, lots of vocabulary, lots of things that they want to show. Nice. Okay, let's take a look at this one. Ooh. Oh, good choice. Okay, here we go. This is Yao's board. Thank you for volunteering, Yao. So brave, always. I don't know if you're always brave, but it's brave to volunteer. So everybody should have the same rectangle, okay? And everybody should have started off the same way that Yao did by creating that kind of right triangle framework around the outside. Now, after a while, don't you think you could not draw these and just figure out the Pythagorean theorem? Yeah, I think so too. You're in high school. We've done the Pythagorean theorem, which probably feels like over 1,000 times at this point. I'm okay with that. And so Yao just kind of has his numbers sketched out, and then up here at the top, he laid out his sides. So 2 of his sides were 2.82, and 2 of his sides were 7.07. But notice how clearly he wrote that, right? He's labeled them as side ZW, side YX, side WX, side ZY. He's labeled all that, and he said that they're equal. Still could be a parallelogram, though, right? Because a parallelogram has 2 pairs of equal sides. Okay, so we're really looking for some perpendicular, right? So I'm going to go over here to something that he says about slope. So we've got ZY is 5 over 5, good. WX is 5 over 5. ZW, this should be negative 2 over 2, right? Because those lines go, when you read them like a sentence left to right, they go down. So these slopes are negative. Okay, so 2 of your slopes are positive and 2 of your slopes are negative. This is excellent, but this work does not show that this is a rectangle. I'm looking for 2 very important words that he did not put down that you may have on your Nerd Alert board that could help Yao really get to that. He has totally proved it, even though he has a phenomenal amount of information on here. What are the words that he needs? Say them. Negative reciprocals. Negative reciprocals. Or something about you wrote 90 degrees. Or you wrote perpendicular. That's the symbol for perpendicular. Okay? Something about having 90-degree angles. Well, 5 over 5 is the same as 1 over 1, right? And 2 over 2 is the same as 1 over 1, and 1 is negative, and 1 is positive. Good question. Now, here's the trap that many of you fell into when you turned in those quizzes last class. You just knew that I wanted to hear negative reciprocals. So you had like an equilateral triangle, and you were like, negative reciprocals. There are no 90-degree angles on an equilateral triangle. You got to be careful. You can't just like say math vocabulary and think that that makes you sound smarter. Because when you say math vocabulary that is not really applicable, then it makes you sound crazy. Like kind of like a math just like Tourette kind of situation, right? So people are saying, well, what do you know about a quadrilateral? And you're yelling about there's 180 degrees in a triangle. Yes, true. But you got to make sure you're talking about negative reciprocals when you're talking about a 90-degree angle. Don't just throw it out there because you think that that's what's right. And the hardest part of this skill is, how do I show things are parallel? How do I show things are perpendicular? The Pythagorean theorem stuff, that's not the hard part. Okay? So today we're going to work on 2 new things about graphing, but we're done with the boards, the markers, and erasers, so if you would go put those up, please. Find this paper, please. Okay, so up until this point, we have been working with how to use Pythagorean theorem to find the distance of a diagonal line. So would you grab yourself a straight edge or a ruler out of your bin? It doesn't matter. Still one of your guys's. Thank you. Oh, yeah. Okay. Would you please connect these 2 lines? So make sure you're on the same side of the paper as I am. And you're sorry, those are not lines, those are points. Excuse me. Connect those 2 points with your ruler. Okay? So find those 2 points. I'm on the side that's got the formula for distance. Up at the top says distance formula. It's got this little weird formula. And I'm connecting those 2 points with a straight line. Okay? So, if I said to you on the state math test, find me the length of this line, you could do this, right? Do it. Find me the length of this line. We just did it. It's hanging up on the orange calendar. Okay, so everybody should have drawn a right triangle. The vertical measurement was 6. Yep. The horizontal was 11. And my answer for the length of the diagonal is 12.53. 52 or 53. That's it. Okay? So now, sometimes the state test will have this phrasing. Okay? Find the length of a line between this point and this point. It won't say this point, it will give you some numbers, okay? So, I'm going to show you how to work around it as well as use the distance formula. But the distance formula is basically Pythagorean theorem, okay? So, on this diagram that we already did, because we already know the length of this line is 12.53 or 52, I'm going to name this point here. So, the end point that was up higher. If I had to name that as a point, what would I call it? Like when I graph it? 4, 3. Okay, so everybody make sure you've got those numbers on your diagram because we're going to need them. Okay, and then we're going to name the lower point of the two the same way. So if I was graphing it, it has a name. -7, -3. Okay? So the state test might say, find the distance between these 2 points. Okay? And you have 2 options. You can just get a piece of graph paper, which you're allowed to have during the state test, and you can graph them, and you can do your little Pythagorean theorem thing because it's super easy for you, and you always get it right, and that's the way I would choose. Or if you're feeling super ambitious, and you'd really like to use the distance formula, we're going to practice it just a couple of times today, okay? The distance formula looks like this. It is on the formula sheet that you are allowed to use during your state test, so it's nothing you have to memorize. And I just want to quickly show you how to use it, so that if you ever have to use it or you see it again, you can figure it out, okay? So, this point here, 4, 3, okay, right above it, we are going to call it x1, y1, because that was the point that we named first. So right above that 4, 3 here, I wrote x1, y1. So I'm naming it to put it properly into that formula. And so that means the -7, -3 is going to be, yep, y2. Okay? So now I'm going to just move over here to where I have a little bit more space, okay? If you feel like you would like to turn your paper sideways and do the work in here, you are more than welcome. You can do it however you want. This is not something I am collecting, okay? So I'm just going to rewrite my distance formula over here. So it's got this long square root bar, and then I've got x2 minus x1 squared plus y2 minus y1 squared. Kalasia, I know that's you. It's always you. Turn that thing off. Am I right?
Yeah.
Yeah, I know. Okay, so we're going to keep the square root bar again, just to get our numbers in to make sure we're in the right spot, okay? So keep your parentheses too. Keep your parentheses also, I should have said. Okay, so first goes in my x2. What number is that? -7. Then I'm keeping the minus sign. That is important. The minus sign is part of the formula. You need to keep it in there. And then what is my x1? 4. Excellent. Good. Okay, so that's my first set of parentheses. And then my second one is going to be y2. So what number is that? -3. And then minus, because minus is part of the formula. And y1 is 3. Okay? So next step, I'm going to simplify a little bit. I'm just going to figure out what's inside the parentheses, because in math, way back when, you should have learned order of operations, and we always do what's in the parentheses first. So just in parentheses, what is -7 minus 4? And if you're not sure, you should be checking yourself on your calculator. -7 minus 4. -11. And then next set of parentheses, what's -3 minus 3? -6. Okay, so from step 2 to step 3, all I did was figure out what's in my parentheses. Now I'm going to square my numbers. Okay, so what's -11 squared? Okay, let me just say this. What are you saying? Thank you. Could you say that louder, please? That was good. Yes. So if you couldn't hear Will, when you multiply two negatives, you get a positive. You have to be smarter than your calculators. Some of you have a calculator that if you do -11 squared, it will give you -121. That is not true. This should be +121. So be careful. Some of you might have to do parentheses on your calculator. So what's -6 squared? 36. Okay. Now I can add those two things up. So 121 plus 36. Moises mumbling quickly. 157. And then I can just square root 157. $12.53 if I know how to round. How do I know that that's the right answer? We already did it. We did the same daggone thing, just Pythagorean theorem. It's exactly the same. Except it's a little bit more steps, and sometimes some of you are pretty sucky with your negatives. So it gets tripped up in here. The only time that I would ever recommend doing the distance formula on your state test is if they give you numbers like, ooh, don't trip, -80 and 106. Why would I say, if they gave you these 2 points, why would I say the distance formula is better? Yeah, who's graphing out 106? You're a little bit crazy. But honestly, if you want 18 sheets of graph paper and you're going to get that question right, if I give you 18 sheets of graph paper, have at it. I don't care. You can be taping on the floor. As long as you're not disrupting our educational environment or our testing situation, tape away, my little friend. Or big friend, depending on who you are in here. Okay? Questions about this? Masla. Go ahead, try. You should be able to answer your own question. Okay, so here are 2 more points. Second example here. Connect these 2 points. Find me the distance of those 2 points, please. You can try the distance formula if you want, or you can just do Pythagorean theorem. It's up to you. But find me the distance between those 2 points. Yes. We did it briefly in here. Okay, 17. How many of you tried distance formula? Nice, brave. How many of you just did Pythagorean theorem? Comfortable, cool, that's fine. Hey, if you got 17, either way, I don't care if it took you longer. If you get 17, that is the point. The point is the right answer, okay? But I will always show you as many ways as I know, because some of you it will work out better for you. Okay, turn it over. Very quickly, we're going to do midpoint. And we'll finish up with midpoint today. So on the back, there is your midpoint formula up at the top. It is also on your formula sheet for your state test. Please take your straight edge and connect the 2 points. Haha, you copied me. I said it wrong the first time. You said what I said, TJ. Points. Okay, so this time, no triangle. This time, no triangle. It's okay if you already drew it. I'm not going to be upset that you have a triangle on your page. This is what I want you to do. I'm going to say it twice, so listen carefully. I want you to guess. Right now, with your pen, I want you to estimate where you think the middle of this is and make a dot. Just look at this line that we have. Estimate where you think the middle is and make a dot. Okay? What I will always recommend to you is checking your midpoint answer graphically. Okay? They're not going to give you crazy numbers where you're going to be laying out 18 sheets of graph paper. But some of you have trouble with negatives. So I would always very quickly graph my section and estimate, just eyeball it. You guys can go, that's about half, even if you're a little off. That will help you know if your answer is correct. Okay, so this is how we do midpoint. First, we're going to name this point here on the left. This point here on the left is -6, -1. Please label it. Dominic, stay with me. This is going to be our x1, y1. It doesn't matter which one you make, x1, y1 and x1, y2. Just keep them consistent. And then this point over here would be what? 9, 3. And so we're going to make this x2, y2. Okay? So now I'm just going to take my formula and plug in the right numbers. All right? So first it says to add up my 2 x's. So x1 is -6 plus 9 divided by 2. So that's going to be my x's. Here, your paper. Then my 2 y's. What's my y1? -1 plus 3 divided by 2. So this is my new point. But you can't leave it like this. Nobody's graphing that. That's weird. So just do this on your calculator. However, do the top 2 numbers first, then divide it by 2. And decimals are okay, because this is math class. Sometimes we have decimals. So what's -6 plus 9 divided by 2? 1.5. Excellent. So that's my x value. And then I'm going to do my y value. So -1 plus 3 divided by 2 is 1. So now I'm going to go back and check my graph. 1.5, 1 is about here. Check your graph. Were you pretty close? Okay? So this formula, hang on just a second, please. This formula will help you be precise because the chances of you guessing like a half of something or a third correctly, it gets a little bit harder. But I always want you to check your work, right? Because if you already guessed and you were like, oh, my answer makes sense because look how close I was, your brain already logically knows what the middle of things is around, even if you're not mathematically as specific as this, right? Okay, so go ahead and do the next one underneath.